Hi everyone, thanks everyone for coming and sacrificing some of your what could be your summer holiday to join us this evening. Just a quick intro. My name's Innes. I work for a recruitment agency. We're called IO Associates. I cover the permanent market in Java in the Southwest. I do recognize a few names. Hi everyone that know me, and hello everyone that doesn't. Today this evening we've got Rupert from YellowDog giving a talk for us. Rupert, would you fancy giving us a quick intro to yourself?
Yeah, hi everyone. My name's Rupert Madden-Abbott. Been a software developer for 10 years, and 8 of those have been with Java. And I previously I was working at University of Bristol. You can see a few people here who I knew from there. So hello, if I haven't seen you in a while, it's good to see your blank screens again. Hello. And now I'm working at YellowDog, which is a small Bristol-based startup.
Cool, perfect. I believe the format of this evening, I believe that the talk itself is going to be roughly about 45-50 minutes. If we just let Rupert just have a roll at that, and then if we can leave all the questions to the end, we'll have a Q&A session. That would be good. So that's it from me. Rupert, it's all over to you, mate.
Awesome, thank you. Cool, so today I'm going to be talking to you about monitoring microservices and how we achieve that at YellowDog. My initial name for this talk was monitoring microservices, and that was very boring. So I naturally asked the question, what is the collective noun for microservices? And was shocked to find that there isn't reams of internet already hotly debating the topic. I could find a single Twitter thread where somebody else came up with the name Murmuration of Microservices, which I really liked, because especially when you're monitoring them, it's almost like you're listening to the fluttering wings of all your microservices and what they're trying to speak to you. Slightly further down the thread, someone suggested a mess of microservices, which unfortunately might be slightly more accurate in some cases. When Innes asked me to do this talk, he had one request, and that is that I do some live coding. So with that in mind, I only have 4 slides to show you, and the rest of it will be demos. Yeah, let's see how that goes. So I just tell you a bit about YellowDog, because it's important to know what we do in order to understand why monitoring is so important for us. So YellowDog's main product is the YellowDog platform. And I like to think of this as comprising 2 core pieces. We do multi-cloud compute provisioning. So this compute can be distributed across all 5 of the major cloud providers and across multiple regions. And we do cloud native workload scheduling. So you might know traditional schedulers like LSF or Slurm that are really designed for on-premise clusters that are fixed, set up in the eons of the past by a sysadmin. No one really knows how to make them work anymore, but they're kind of there and they exist and they're always on and they're always costing money. Our scheduler is designed to work both with the restrictions and the freedoms afforded by the cloud. So essentially, we let you spin up very, very large amounts of compute across the planet and then put that compute to work for you. So as you can imagine, this is a very highly distributed and concurrent system, which means we need excellent runtime insight into what our various technical components are doing. And that brings me on to monitoring. So what do we actually need to monitor? So we've got a bunch of our microservices sitting there, hopefully doing what they should be doing. For us, that's either Spring Boot applications or what we call foundational services, so things like databases or message queues, that kind of thing. When you're using our scheduler, every compute node that you bring up in the cloud also is provisioned with our agent running on it. And our agent is responsible for calling back to our microservices, calling back, asking if you've got any work for me, and then ensuring that whatever that work is gets executed on that node. So, the kinds of things, that you might run on our platform would include, CGI rendering for films. For example, you'd split those into loads of frames. You can imagine each one of these agents rendering an individual one of those frames, communicating back with these microservices to receive the work and coordinating all of that. Drug discovery is another good one, rotating proteins to see if they fit together. That kind of thing. So what do we use to monitor them? So we use Prometheus. So Prometheus is designed to ingest metrics from our microservices, and it's a time series database. So it regularly pulls metrics of a well-defined HTTP endpoint from each of these microservices and then stores it in its time series database for later querying and analysis. And then we've got Loki, and Loki's official tagline is "like Prometheus, but for logs," which I think says it very clearly. Unlike Prometheus, it is not a pull, it is a push. So you need to run, you need some way to get your logs off your microservices and off our agents and into Loki. One way to do that is to use our official agent, which is called Promtail. So we run that on our microservice nodes, and we also run that on we can run that on our agent machines, and this pushes logs back to Loki. And finally, there's Grafana. So Grafana is our front end for both Prometheus and Loki, and it lets us draw very pretty graphs and make sense of all this data. Simple. So let's go and do it. So there's no more slides. I'm going to give you 2 demos. The first will be building that from scratch with a couple of Spring Boot microservices and showing you how we integrate them into that monitoring stack. And the second will be seeing how we then make use of that same monitoring stack at YellowDog. Okay, so I want to make a simple game. It's going to be a variation of Hangman, which is terribly unoriginal. I do apologize. But we're going to have 2 microservices involved. We're going to have a random word generator, and we're going to have a game microservice that lets people actually it will use the word microservice to choose a random word, and it will let people make guesses and either win or lose. So what I've got here is a standard multi-module Maven project. At the top level, I've got a, can everyone read this okay? Is this legible for everyone?
Yes.
Lovely, thank you, Ben. So I've got a parent POM here, and I'm inheriting from the Spring Boot starter parent, which is basically just pulling in a bunch of build configurations, so I don't need to define it myself. I'm saying I'd like to use Java 16, not that that particularly matters for this demo. And I've got a couple of modules, one for each one of my microservices. I'm declaring a shared dependency that I want both of these microservices to use, so Spring Boot Starter Web. So both of these are going to turn into web applications. And I'm configuring Spring Boot's Maven plugin. So I'm configuring it to make use of its new built-in Docker image creation. So when I do a Maven package, this is not going to spit out fat jars. This is going to spit out Docker images. Looking at the microservices, at the moment they're very simple. They simply inherit from that parent I just showed you, and they activate that Maven plugin. And the game one is identical. And then I've got a single application class, which is a very simple main method if you're familiar with Spring Boot. Effectively, what this is doing is it's just starting a Spring Boot application. And because of the dependencies got in my class path, it's going to turn it into a web application. I am going to assume quite a lot of Spring Boot knowledge, but I will try and give people the sort of highlights so you don't get completely lost. Okay, so let's go ahead and try and implement this. Let's start off with my word generator. So I need a source of words, and I've got a dictionary here that I prepared earlier. It's very big, so I'm I'm not going to open that too long because I don't know how IntelliJ will handle that. Probably not very well. And what I quite like to do is on application startup, I want to load that into memory. So in Spring Boot, you declare an application runner, which says do this at startup. And I'm going to use another piece of Spring machinery called a resource loader. So this is a sort of a Spring convenience layer to load stuff. So I'm going to go from the top of my class path, and I'm going to load in words.json. And let's store that in a variable. Now I've got a reference to that file I've added in. Now let's load it. So to parse this JSON file, I'm going to use Json, which is a JSON parser. So I'm going to read that file. I want to turn it into a list of strings, which is, so I need to do a bit of generic handling here. And I'm just going to store that in a variable called words. Okay, there we go. So that's going to happen at startup. Now I just want one endpoint on this microservice, and that's going to generate me a random word every time it gets hit. So I'm going to turn this into a controller. Let's add in. So it's just going to return a string right directly in the response body. So let's see. So I want to get something randomly from my list. So let's do new random. And I want a random integer somewhere in the size of my list. Return that. And I'm just going to make that available. So that will be available at the root of my application. So let's just run this and make sure it works. I bet you anything I've got something running on port 8080 elsewhere. Yes, I do indeed. Let's just shut everything down. Is it gone? It's gone. Oh, that's quite a lot more information than I was expecting. Let's just try that again. Okay, there we go, that's better. So I've got my web application running on port 8080. So to test this, I'm going to use one of my favorite features of IntelliJ, which is their text-based HTTP client. So you can say get localhost 8080. I can run that. And there we go. Oh, castration, that's a great first word to get. So I haven't removed any rude words or swear words from this. So clicking this button is a little bit like playing Russian roulette. But it looks like after castration, I'm going to get quite lucky. There we go, nannies. That's a perfectly normal word. Raisiny. Oh, lovely. You're never going to guess that. This is quite an interesting dictionary. It's quite large. So that's my random word generator working. So now I'm going to do the game, which will be ever so slightly more involved, but not terribly. So I'd like people to be able to kind of create a game and then make several guesses against that game and either fail, lose because they go over the required number of guesses, or win because they guess the word. So I think I need 2 endpoints for that. I'd like to create. We'll do a post mapping because it's changing state. So I need some kind of class to store this, store my games. And I think the first thing I'm going to need is I'm going to need my game to store what word they're supposed to be guessing, right? So let's create a new game. So I'm just going to stub out a method here, get random words. And for the moment, I'm just going to return a single word micro, but in a moment, I will convert that over to use the mobile microservice. I want my game to have a unique identifier identifier. My idea here is I'm going to return that back to the user, and then on the next endpoint, they'll use that to play the game. So let's go ahead and do that. So I'm getting a random UID here. Oh, let's call that something more sensible, game ID. So I want someone to store my games, so let's just do it in memory. Okay, so I'm going to, it's a map of the game IDs to the games themselves, and then I'm just going to return the game ID back to the user. Lovely. That's my create endpoint. So after the user creates the game, they want to be able to play it. And I think I'm going to need 2 bits of information here. So I'll do a post again, because it's still a kind of, you're still mutating state. But this time I want it to be at the game ID. And you know what? I'm going to put all of this under a, I need to make it a controller. I'm going to put it all under a path of games. So people have to go to /games, posting to /games will create a game, and going to /games / the ID of the game will let you play it. And so I need 2 bits of information. So I'm going to get one from the path to be game ID, and the other bit I'm expecting to be in the request body. So that'll be the guess. It's just going to be a single character, not a string. So the first thing I need to do is get their game out of the map. So if it doesn't exist, we'll just do some really basic error handling here. If it's null, we're going to throw, and we want to return a 404. So Spring's got this handy response status exception, and you just go not found, and that'll make sure they get 404 back. Okay. Otherwise, what do we want to do? So we want to check. Does the game word include their guess? So if it doesn't exist, then let's see. So I think we need to keep track of how many remaining guesses they've got. So we'll decrement the remaining guesses. Let's initialize this to 6. Does that seem fair? Yeah, let's try 6. That shouldn't be too taxing for me, I hope, especially when I've hard-coded the word. So the next thing, right, I'm going to need some way to track the correct guesses. So my idea here is you store the correct guesses, and then we'll kind of dynamically work out whether or not they've got the right answer. So let's have a set of characters, correct guesses. We can initialize that. So I'm doing it all in one file purely for demo purposes. I strongly recommend you split your code out into multiple files, but it's just easier when you're presenting to do it all in one thing. Okay, so either they got it wrong and we're going to remove one of their guesses, or they got it right and we'll store it. So the next thing we need to do is see if they've lost because they've run out of guesses. So if remaining guesses is less than 1, we will delete their game because it's no longer in progress, and we will return you lose. And we'll tell them what the word is because we're feeling nice. The word they failed to guess. So now we need to, otherwise, either they got the guess, either they got a correct guess, or they got an incorrect guess, or they've won. So my idea is if they've got a correct guess, what I want to do is return them a kind of a string with the guesses they've got showing those letters, and the other letters masked out as like asterisks or something. So let's split this into individual characters, and then we're going to map each one. So for each character, we want to look in our correct guesses, and we want to see if it contains the character. So this is actually, I've got a list of strings here, but each one of these strings will be one character. So I'm saying get the first character of the string. There's only one. It's a little bit hacky, but it will do for now. So if the character that in this word does exist in the correct guesses, then we'll reveal it to them. Otherwise, we'll return a star. and then we'll just throw that back. So this will be the masked word. So if the masked word equals game.words, then we can remove their game because they've won, and we can say return you win. And we'll tell them what the word was. Otherwise, they're still trying. So we'll tell them how many remaining guesses they've got less. Guess. And we'll tell them what the masked word is so they can make some more intelligent guesses. So other than the fact that I've hard-coded it, this is good to go. So let's test it out. So we're going to post to localhost 8080. Now I've got to remember to shut down that other one because everything's running in port 8080 at the moment. To run my game up. /games. And what you can do with this, I'm just going to copy and paste this bit because I can never remember the syntax, but you can effectively what I'm doing is I'm grabbing the response of this and I'm storing it in a global variable called game ID. And it'll just be available to me for subsequent requests. So let's give that a run. There's my UID that's come back. So that will now be available to me in this game ID variable. So now let's play the game. Post localhost 8080 games, and then let's reference that game ID. I think that's right, syntax. And I want to make a guess. So let's make an incorrect guess. So we know the word is micro, yeah, because I've hard-coded it. So excellent. So there were 6 guesses. So now there are 5, and all those asterisks are there. Let's do a correct guess. Lovely. Let's do one in the middle of the word. Okay, and now let's just make sure we can win this game. Lovely. There we go, you win. So if I run this again, right, the game shouldn't exist anymore, so it should get a 404. Lovely. Okay, so so my game's nearly implemented. The only thing I need to do is stop stubbing this out. So that's very easy to do. I just need another dependency. So I'm using here web client, which is part of WebFlux, which is Spring's reactive, non-blocking, asynchronous HTTP layer. I'm doing that because my understanding of the Spring roadmap is their older blocking client REST template is going to get deprecated at some point. So and web client will be the way forward. So I don't know if that will actually happen, but you can do both synchronous blocking stuff with web client, or you can do asynchronous reactive stuff. So I'm only going to use it for synchronous stuff today, but that's why I'm doing that. Oh, I need to refresh my Maven configuration. Okay. So Spring doesn't actually inject one of these for you. What it does is it makes a builder available for you. But that's fine. Because I can just build it. And then down here, using it is very easy. So the URI, so this is all going to be running in Docker Compose. I did try and get this running on Kate, but you know, I'm not an ops person and the complexity escaped me slightly. So we're on Docker Compose because it's nice and easy for my poor developer brain. So it's got its own internal network. So it's going to hit the words container at words.8080. So we want to retrieve that. We want to map that to a string, and then we want to block until it's ready. So that should be sufficient. Okay. So the next step is to get our Docker Compose running, and then we can see all this running as containers. So I'm going to declare a service for my game, and the image will be derived by Spring from the artifact ID, which is game, and the version, which is 1.0 snapshot. And I want to expose some ports here so I can actually access it from outside and play my game. So I'm going to map port 8080 on the host to port 8080 in the container. And then I'm going to do the same for my words. I'm going to expose this one as well. I don't have to because it's only used by game, but I want to be able to access it from outside so I can test that it works and just show you what it looks like for other reasons. So I'm going to map that to port 8081 on the container. So now I can just go ahead and build this. So just running Maven package, and that's going to spit out 2 Docker images locally, interacting with the Docker client that I've got running. Just give it a moment, there we go. And now I'm going to spin up Docker Compose. Oh, there you go. I knew I'd forget to run it. So I've still got game running, so that failed because I'm running too many things on port 8080. Let's try again. Okay, so that's all working fine. So now I can go to a browser, reload. I tell you what, why don't I just use the requests? So the random word generator should be available at 8081. Oh, there we go. Oh, anti-electrons, that's a good word. Superb, that is a superb word, brilliant. Let's try playing a game, and this time we want to make sure we get a random word back, right? So there's my game ID. That is definitely not micro, whatever that is. So we can safely say that is a random word. Okay, so my microservices are complete. So now I want to start monitoring them. So let's start by adding in the first of our monitoring stack, which is going to be Prometheus. So I'm actually going to build Prometheus from scratch. And the reason is I want to add in some configuration. You could use a bind mount here to add in the configuration. But I'm not a massive fan of that because you can run into permissions problems. So my preference is to just build them from scratch. I think it's just as easy. So here's a Dockerfile I prepared earlier. It's very simple. I'm just pulling from the upstream Prometheus Docker image, and I'm going to copy a YAML file in, which I'm going to just go through with you so you know how Prometheus works. So I mentioned to you earlier that Prometheus wants to scrape, it wants to hit at a regular interval a well-defined endpoint at each one of your microservices. So here I'm telling it I want you to scrape those endpoints every 5 seconds. By default, it's a minute, and that's no one's got time for that. So 5 seconds it is. And here I'm defining 2 scrape configs, one for words and one for game. And we're hitting those internal Docker network endpoints. So words 8080 and game 8080. Now I said it's going to hit a well-defined endpoint. So if I actually run this up, you'll see that this is not going to work yet. Oh, I'm also exposing Prometheus. So Prometheus actually has its own web UI. It's nowhere near as good as Grafana in terms of ease of use or what you can do, but it's very functional. I'm not going to go into much detail about it other than to say that it's got this very handy targets endpoint, which tells you whether it's been able to successfully do the scrape or not. So it shows you when it last tried to do a scrape, how long it took, and whether it was successful or not. So you can see these are very much not okay. So let's open up the game and let's go to /metrics. And as you can see, it doesn't work. And that's because we need to do a bit more configuration in Spring Boot to get that working. So at the top level, I'm going to add in 2 more dependencies. So I'm adding in here Spring Boot's Actuator, which basically adds in a whole bunch of runtime ops style endpoints. So you've got health checks, you can expose your logging, you can expose JMX to change a whole bunch of stuff at runtime. There's lots and lots of good stuff in there, and you also get metrics. The underlying metrics implementation that Spring Boot uses is called Micrometer. And to get Micrometer working with Prometheus, you need a plugin. So here is that plugin. So this is going to make sure that the metrics page we publish is in a format that Prometheus can consume. So I've done that at the top level. We need to do a little bit more. So we want I'm going to add some configuration into our applications. I'm just going to copy and paste this because I don't need to watch me type all this out. So here, by default, Spring Boot exposes only the health endpoint for security reasons. So I'm saying, no, I would like you to expose the Prometheus endpoint, please. And again, by default, Spring Boot will expose this at /Actuator/Prometheus. It's up to you whether or not you want to configure Prometheus to know the Spring Boot conventions, or whether you want to configure Spring Boot to know the Prometheus conventions. In my opinion, it's better to make Spring Boot aware of Prometheus's conventions, and then Prometheus can sort of sit above a whole range of different things without, needing to care that this is a Spring Boot application, and this is a Python application, and this is a Mongo database. So I'm saying, please, instead of whacking Actuator in the path, please can you serve this from the root? And then I'm doing a path mapping. So I'm saying, instead of revealing this as Prometheus, please can you reveal this as metrics? So I'm going to do that in both my services. I'm going to build them, wait for them to build. It's so fast. I love Docker. So fast. And then I'm just going to redeploy everything. And now, if I refresh this, okay, one of them. Oh, there we go. Good, good, good. I'm just too impatient. So this is great. So it's been able to connect to them, and you can see by the last scrape times, the last scrape times are not going above 5 seconds there. So you can tell that it's trying again every 5 seconds. If we look at the metrics, this is what you keep in mind. I've done barely any configuration here. This is just what you get by default. So you get a ton of stuff. It's all relevant to what you have added onto your class path. So there's a ton of generic stuff around, JVM memory here. You get some stuff specific to Tomcat because I'm using Tomcat as my server. That's the default. There's some specific stuff around logback here. Again, logback is a particular logging implementation. As far as I know, if you swap these out, you swap Tomcat out for Undertow, swap logback out for another logging implementation, you'll start seeing metrics for those instead. So there's a ton of really useful information you just get for default here. None of it specific to your application logic, but that's okay. We can add that in. So that's Prometheus up and working. So the next thing we want to add in is our logging. So let's go and do that. Where's my window gone? There it is. Okay. Okay, so remember, Loki works the opposite way. So Prometheus pulls the metrics in. Loki wants you to push the logs to it, and it does that using Promtail. So we're going to run Promtail. And the way I'm going to do this is all of these two containers, they're logging to standard out, and those logs are then getting captured by Docker, and they're actually getting written to a disk on the host. And they're getting written to disk on the host in this location via the Docker containers. So I'm going to cheat, and I'm going to host that. I'm going to make that available to Promtail, and then Promtail is just going to kind of regurgitate them back up into Loki. Now again, I'm going to do a build of Promtail here because I want to add in some configuration. So here's the Docker file I prepared earlier. Again, it's very simple. I'm just pulling from the upstream Promtail. I'm going to add in a config file, and with Promtail, you've got to tell it if you want to use custom config file. So all I'm doing here is just passing in this additional variable to say, please use my custom one. And then here's what here is what that config file looks like. So it's a bit longer, but it's not doing too much. We need to tell it where Loki is. So again, it's internal Docker. It will be here. It's not there yet, but we will put it there. So it'll be at Loki 3100, which is the default port. This is all the default. And then we define, just like did for Prometheus, we define a scrape config. So there's a single job here called system for no particular reason. That's just copied straight out of their docs. And you tell it how you want, which paths it should consider. So remember, I mounted the Docker logs at /containers. And the structure of those logs is you get, I think, a container ID, and then you get inside there a log file. So that's how it's finding them. And then you define some pipeline stages, and the pipeline stages define how Promtail is going to scrape those logs. So Docker logs as JSON, and it logs out a kind of a log line, a raw log line from the underlying service in a log key, and it logs out a timestamp, and I think it logs out a stream as well, telling you whether it's standard out or standard error. So here you see I'm saying, well, I want to scrape it as JSON, and these are the bits I want. I want the log, I want the timestamp, and I'm going to put in a custom tag as well. I'm going to show you. I'm going to add in that custom tag shortly. I'm actually going to make my Spring Boot application, make this really simple. I'm going to make my Spring Boot applications also log JSON. So it's going to be JSON nested inside JSON here. So this log line here that I'm pulling out itself is going to be JSON. So I'm going to parse that again, and I'm going to pull out the level, info, warn, error. I'm going to pull out the message, this time not in JSON. I'm not going 3 levels deep. The timestamp according to Java, the logger name, the stack trace if there is one, and the thread name. You can add, whatever you like to this, of course, but this is what you get by default. And then of those pieces that I'm extracting out, I'm going to choose which ones I want to turn into labels. Now, you don't want to choose something that's got a high, it is very, very variable for a label, because it's going to dramatically increase the amount of disk space that Loki needs to handle your logs. So something like level is absolutely fine. There's only sort of 5 possible values for that, right? 4 or 5 values. For service, that's going to be either the game or the word. So again, depending on how many microservices you've got, it's not going to be all that many, right? Something that would not be a good idea would be something like user ID, okay? Because hopefully you're going to have a lot of users, and that probably won't play well. But that's okay, because Loki is also very, very fast at doing dynamic searches. So that's no problem. These are kind of your top level. You go, right, I'd like to see my error logs from my game, please. And then you can still, if you want, filter that down to a particular user. But you do that dynamically rather than statically. Then I've just got a bit of handling here because we won't always have a stack trace. And if we don't have a stack trace, it will very helpfully output triangular brackets, no value, which is really, really helpful. So this effectively just outputs nothing if there's not a stack trace. And JSON's great for parsing, very reliable, but it's not great for readability. So I'm now actually converting the JSON back into a human readable log line for display in Loki and Grafana. So I'm uppercasing the level name, space, got the logger name, space, I'm putting the thread name in square brackets, and I'm putting the message in, and then if there is one, I'm putting in the stack trace. I'm telling Loki where to find the timestamp and what format it's in. And then finally, this template I'm storing in a variable called line. And then at the end of it, what I'm outputting is this very thing. So that's what's going to go into Loki and Grafana, and not the raw JSON. You could put the raw JSON if you want. Okay, so now I've got to make my Spring Boot applications output JSON. This depends on what logging implementation you're using. The default Spring Boot one is logback, so that's what I'm going to do. So there's another dependency I'm going to add in here, this logstash logback encoder. This can do a whole bunch of stuff, and as you can see, it's the competing framework logstash, part of the Elk stack, but for our purposes, all it's going to do is transform our logs into JSON, so that's fine. And then we need to add some logback configuration. So Spring Boot supports this logback-spring file, and it's really neat because what it lets you do is define profile-specific logging configuration. So if you don't specify a Spring profile, it will just do the default console logs that you've seen pop up previously. But if we enable this profile JSON logs, then it will output JSON logs. So what I'd really like as a developer is if I'm just running it in my IDE, I don't want JSON logs. I just want to see the readable, human readable logs. But when I'm running it in Docker, I'm not, I'm probably, or Kates or whatever, I'm going to be, this is all going to be clustered. So I'm not going to be reading the logs directly out of them. I'm going to be using Loki or Grafana to read them. So that's fine. You can have JSON logs there, and then I'll read the nice readable logs in my Grafana interface. The last little bit I want to do is turn off the Spring banner, which you may have seen flying past on the logs there. It's that sort of SDR thing. I just want to switch that off because it doesn't play well with my Prometheus scraper, and we don't need it, so let's just turn it off. Let's copy that over there as well. So the last little bit is I'd quite like a name for to associate the logs that are coming out of game with this service, and equally a name for words. There's two ways of doing this. You could do it in Spring Boot. You could use an application name or something like that. It's a perfectly valid approach. Not a massive fan of it because it's Spring Boot specific, and you might want to have something more generic that works for everything. One thing you can do is to use either container name or image name coming from Docker itself. Only problem with using container name is Docker is currently generating container name dynamically, and that's really neat because if we want to cluster game or words or something like that, it allows us to do so. If you statically set a container name, it's not going to work. So for these particular purposes, I'm going to use image name. And the way you do that is with a bit of logging configuration at the top here. So this is just how you configure Docker logging configuration. And I'm adding in a tag here of image name. And if you remember in the Promtail configuration, that's where this service is coming from. So it's going to pick up the image name. So the image name is either going to be game 1.0 snapshot or words 1.0 snapshot. And then I just need to add that into each one of my services. So I'm only looking at game and words here, so I'm only going to add it in there. And that's Promtail configured. So the next thing I think need is Loki, and Loki is dead simple. I don't need to do any configuration there, I just need to whack it in, and that's it. And then finally, I need Grafana, and Grafana is unlike. I think you can create, you can create Loki directly, but I'm not familiar enough with its API, and there's no web interface. So to validate that the logs are working, I'm just going to add Grafana in now and validate that it works through Grafana itself. So again, I want to build a custom Grafana image, but it's very lightweight. Here is one that I created earlier. So again, I'm pulling from the Grafana upstream stable version, and I'm copying a bunch of stuff in. So I'm going to go through these configuration files with you one by one. They're not doing a huge amount. So we've got grafana.ini, and what this does is just turns off all of Grafana's authentication, so that as I continually restart this and show it to you, I'm not also continually having to log in. You wouldn't do this in production. I'm going to add in a data source YAML, and this tells Grafana how to find Prometheus and how to find Loki. Simple. And then I'm going to add in some dashboards. So this dashboard.yaml is just saying load dashboards from this location, var lib grafana dashboards. And you'll note in Docker, in my Dockerfile, I am copying dashboards game.json, which is here, to var lib grafana dashboards game.json. So this just means whenever Grafana starts up, it will have a sort of a pre-made dashboard. So the kind of workflow you get in Grafana is you go in, it's empty, you fiddle around with it, you create a dashboard, get it looking nice, and when it's in a state you're happy with, you can pull it out and add it to this sort of special provisioning area, and then it will just make it available whenever you deploy Grafana again, which is really powerful. Okay, I think that might be it. Let's give it a run. Let's have a look at Grafana. Okay, so Grafana is working. So the first thing I want to do is check, is Loki working? So this is, I went to explore there and I selected the Loki data source, and you've got this log browser, which is helpful if you're not familiar with the logql syntax. I'm not massively familiar with it, so I do find this quite helpful, but you can just type it in if you know it. So as you can see, it's picked up the service labels. So let's have a look at the logs of my game service, show logs. Brilliant. They've not come in correctly. How disappointing. Let me just see if I can fix that. I think I might know what it is. It's a problem with a live demo. It all goes horribly wrong. I'm just going to do the classic turn it off and back on again. Okay, so unfortunately there, I can't show you it coming in wonderfully well. So this should not be coming in as these log lines as you can see them here. They should be being parsed correctly. I feel like it hasn't. Give me one more chance to get this. Maybe I need to rebuild. Maybe I didn't rebuild my microservices. Oh, I know what it is. Yeah, I know what it is. Okay. So I've got to activate that profile, that Spring profile. So I want to enable the JSON login. So what we were seeing there is it is in JSON, but this is the Docker JSON format. But the Java is still coming through in the standard plain text, whereas I want JSON nested inside of JSON. Can never have too much JSON. Okay, let's give that another run. Oh, yeah, I'm just gonna, it'll have the old logs in there, so I'm just gonna pull it down and bring it back up again. I'm not preserving any state between deployments. It's all just what you see here, so it's very easy for me to reset it. Okay, let's bring up everything again. Hooray, okay, we got there in the end. So I've noticed that when you run Spring Boot via its built Docker container, you also get a bunch of differently formatted logs at the beginning. So you can see they've come through not correctly parsed. But let's not worry about that. Here are the correctly parsed logs. So you can do things like add in multiple levels here, multiple labels. So you can say, right, I want to look at particularly all the error logs, for example, although there aren't any. We'll get nothing, but I can say, well, I'm just interested in info. And then you can filter dynamically further. So, we could have, as I said, when I was talking about user ID, I could have added in the logger name as a label, but that again would be a bad choice because you might get hundreds or thousands of logger names. And that's going to be quite complicated for Loki to store. And it's dead easy to filter on it. You just do colon equals. You can do regex here. You can do whatever you like. So this is really powerful, especially imagine if you had 4 or 5 of your game services running clustered, or you were searching across hundreds of microservices all in one place. This is exactly what you want. Let me just check how we're doing for time. Okay, so that's my logs. So the other thing is metrics. So one of the lovely things you can do with Grafana is you can import dashboards. So I'm going to import this one from Grafana. So this is a dashboard that's maintained by the Micrometer guys. So you just need to tell it what data source to use. So we want to use this Prometheus data source, import. Kind of vaguely hoping to see something more than that. Let's just double check. How unfortunate. Let's have a look over the, so up in the right-hand corner, you've kind of got the resolution that Grafana's looking over. It's looking over the last 24 hours. If we look over the last 15 minutes, there we go. Thank you, Ben, who popped me the right answer there. So I'm looking over the last 15 minutes. You can have it auto-refresh every however long. So let's make it auto-refresh every 5 seconds. You can see you get a ton of useful information here, graph views. We've got information about the memory, thread usage, more memory, garbage collection, class loading, tons and tons of low-level stuff for free, which is lovely. So that's great, but I would quite like to add in some application level metrics. So what would that look like? So if we switch back to our application, so I'd like some kind of, what's going on with my games? Who's playing my games? How are they doing? Are they succeeding? Are they failing? That kind of stuff. So I want some counters. So counters, these are part of the micrometer library. Counters always count upwards. And Spring Boot gives you a metric registry dependency you can inject. Sorry, meter registry. So I'm just kind of registering 4 counters here. So these are 4 numbers or groups of numbers that I want to appear on my metrics, published to my metrics endpoint. And I'm naming them here game, because this is the game service. And I've got guesses, correct total, guesses, incorrect total, games won total, and games lost total. So here I'm just kind of registering these counters. Now I need to make use of them. So, so here's where we have an incorrect guess. Now, in my opinion, you should increment your metrics after mutating state, because the state mutation might fail. So incorrect guesses counter increment. Incorrect guesses counter increment. And here's where we win. So again, we'll do it after we've mutated the state. So 1 games counter increment and lost games count increment. So the counters. So that's quite handy. I'll show you in a moment how we can use that to see a kind of a rate. Oh, I've got it the wrong way around. Again, I think Ben is sending me helpful messages, saving me from very painful errors in my debugging later on. Thank you very much. So yes, I do want to increment the lost games counter when we lose, and not the won games counter. So we can use these later on to show a kind of a rate of how rapidly people are winning and losing games as they're using the platform, and how rapidly they're guessing correctly and incorrectly. So how good are my players? Another type of metric is a timer. And you can add this in yourself. There's a timer annotation, or you can get access to a timer manually if you want to time particular pieces of code. But Spring Boot by default automatically times all of your request endpoints. So we don't need to do anything. We'll get that for free, and I'll show you in a moment. And the last type of metric is a gauge. And a gauge is a bit like a counter, except it can go up and down. So here I'm adding a gauge called games total, and what it's going to do is it's going to track this this map, and it's going to track its size. So whenever someone goes to the metrics endpoint, it's going to tell it how big is this map. Now I've written a little bit of automation here that basically just simulates tons and tons of people playing my game. So I've got that running in the background. And I'm going to navigate over to the game dashboard, so created earlier. Oh, I need to do a rebuild and restart, don't I? Because I've added them in, but they're not deployed. I think that's ready. Right, let's so yeah, let me go through. Annoyingly, it hasn't saved my. Let me just edit this. So what I actually want here is the game go. Let's get rid of that one. So as you can see, it's really easy to edit on the fly, although none of my changes get persisted, and I think I just forgot to save the last one. But oh well, it's very easy to recreate. So I've got 4 graphs here. This, if I had saved the title, would say average quest times. So as you can see, it's kind of the metric names are generated by the controller endpoint. So this slash is actually coming from the random word query. So you can see that's, you know, all of these are, you know, blindingly fast. So there's nothing really to you know, splitting hair to look at the difference between these two, but that's particularly fast. Then we've got slash games, that's people creating games. You can see that sort of happening relatively intermittently, but they're not constantly creating games because they're spending some time playing them. And then these are the guesses that are going on here. So they're going on pretty continuously. And then the metrics endpoint is getting hit every 5 seconds. This will actually be aggregated. There's 2 metrics endpoints. It's actually getting aggregated across both microservices. You can see here, effectively, I'm getting the metric. This is what Spring Boot chooses to export as. And I'm saying I want the average over 30 seconds, and I want the rate, and I'm summing it if there's multiple. And I'm splitting up by URI. So if I didn't have the by URI there, then I just get a sort of a total average request time across the whole thing. But you could equally partition this by, you know, service or a whole variety of other things. You can filter the URL. So if you wanted URLs that were particular to one service to appear here with perhaps some kind of prefix here, so you could distinguish them. Let's say all of them had a root URL, and then you could add it in multiple times, each for a different service, something like that. There's lots of powerful things you could do here. We've got the game's totals. This is our gauge, so you can see it goes up and down. And this is literally just giving us a kind of a semi-live view of that games map. So you can see on average, we've got about 15 people at any one time running a game. Here's the rate of games. You can see my players are absolutely abysmal. They've barely won any games. They're constantly losing. And that is because they are just guessing random letters, and they're not even ensuring they don't guess the same random letter again and again and again. And you can see the loss rate tallies very nicely with the guess rate. You see they are getting some correct guesses, but by and large they're getting incorrect guesses, which is to be expected. So there's our game microservice. I'd like to just switch over now to the YellowDog platform to show you kind of the same thing, but on our how we make use of it. So so this is our portal. This is our UI to the YellowDog platform. Our lovely, lovely UI. It's going to log in. So I'm gonna, again, I've got some automation here, which is gonna spin this up for me. Let's just run this. It's just running now. Okay, lovely. So okay. So the most basic kind of entity in the YellowDog system, I guess, is a compute requirement, which is your manifestation of your need as a developer for some compute. So I've said here, I'd like 100 instances, please, and I'd like them all to come from AWS, and I'd like them to all come from the EUS2 region, and I'd like them to be of the shape T3 small. And YellowDog has gone away and done that for me. So I could have said I'd like some here from Oracle, some from AWS. I'd like a mixture of on-demand and spot. I'd like them to be all across the planet, mixture of machine shapes, whatever you like, and they'd all get joined together into a single compute requirement I kind of managed together. So I've got my 100 instances all running now. Now you can just use that compute directly for whatever you might want to use it for. But you can also use it with our scheduler. And when you use it as our scheduler, as I mentioned earlier, on every single one of those nodes, our agent is running on it. And when the machine starts up, our agent will call back to the platform and register itself. And that's what you're seeing on this screen. So you can run a number of workers on each node if they're very large and you've got lots of cores and you've got a single-threaded process. Maybe you want to run one worker per core or something like that. But you can see I've got 100 workers because I've gone for one worker per machine. And the other thing you're going to need is some work. So I've got a very, very basic definition of work, so work requirement. And I've got a number of tasks. I've got 10,000 tasks. And as you can see, the workers are just absolutely stripping through them. There's already 6,000 completed. And that's because it's a very, very noddy task. I'm asking them to sleep for 0 seconds, which we should definitely hope that they can handle quite quickly. So the portal's fantastic for giving our users a kind of a live view of what's happening right now. But Grafana is how we get a view of what has happened. So let me go to our Grafana endpoint. So this is the dashboard that we used previously. Unfortunately, some of these graphs are currently broken. I wasn't able to get them fixed before this demo, but I will show you the graphs that are working. So firstly, up in the top right corner, we've got these requests showing the requests are making out to the various providers: Azure, Google, Alibaba, OCI, and AWS. I've only made use of AWS, so we can only see requests going out. And as you can imagine, the way that's implemented is when we make requests out to these providers, we are incrementing a micrometer counter, which is then getting published out to an endpoint and then getting scraped. And this handles that fine. We could run 100 instances of our compute service, and we could scrape from all those endpoints, and they'd each be reporting how many individual AW requests each one of those microservices have made, and Grafana would aggregate it all and display that as a lovely total, so we don't need to worry about any of that. Or if we want, we can see exactly how many each one's doing in case there's a problem with one of them. You can see here we're kind of breaking it down by some additional dimensions. So we're sort of we do retries, and sometimes we're asked to retry because we're rate limited by the provider. Most often we're successful, or sometimes there's a sort of a more permanent error. So you can see we can distinguish what sort of requests are going on here, and that's a custom label that we're adding into the counter metric when we add it. So we're going, here we've got worker requests. So this is the very similar to the average request times that I showed you previously. We've got a large mixture of requests here. There's some sort of quite long background thread type tasks going on. So we're not just relying on the Spring Boot endpoint automatic timings. We're also making use of some timer annotations or kind of measuring bits of code. So it's really neat. You can get kind of slice it. If you've got a very long running request, you can kind of put additional timers wrapping around increasingly smaller nuggets of logic. So you can kind of get a really good view of like, oh, this is the bit that's running slowly. And then a very important metric for us is how quickly we can allocate tasks to workers. And that's what this is showing here. So again, we've currently got 3 schedulers running. The workers are all calling in very rapidly, trying to get their work. They're completing it very quickly, so they're calling back in very, very rapidly. This is how we give ourselves insight into how well we're doing. And is sort of what drives, I guess, our performance improvements. One of the things that drives our performance improvements. I do know that it's only so it's got nearly about 200 allocates a second, and I can assure you that is very much limited purely by the number of machines that So I've only booted up 100 machines. If I booted up any more, it would be a lot faster. I just switched back to the portal, and as you can see, the work was finished, so my computer's been automatically terminated for me, so it's not costing me any money anymore. And that's everything. I think I'm over 1 hour and 2 minutes, so I will stop speaking there and hand back to Ines. Thank you very much for your time, everyone.
Thanks, Rupert. Thanks Thanks for that. Yeah, massive virtual round of applause from everyone. This, even though I don't think you can see anyone. Any questions? I know there isn't many of us, so do feel free just to unmute yourself if you've got a question and ask away.
Can't promise I'll be able to answer any of them. But, you know, take your chances.
A few thanks.
Yeah, it's not on GitHub at the moment, but I will upload that whole repository that I've just written live. I'll upload that.
Cool, perfect. Any other questions? I think you've gotten away with not having to answer any of this.
Was that a bit too fast paced for people? Was it useful having a live demo? Would it have been better to sort of have a slower pace through slides? If anyone's got any feedback, it'd be much appreciated. Thank you. I take all tips constructively.
Yeah, I think certainly from previous feedback, Rupert, is that there probably isn't enough live coding or live demoing. And it seems to be quite sort of lecture-y heavy in terms of slides and sort of the classic presentation. And you correct me if I'm wrong, everyone, but yeah, I think sort of live demo is certainly I think more engaging, and it's more live, I guess, than if you were just to deliver a lecture type, presentation.
Was everyone familiar with this monitoring stack already, or was this sort of new to most people? The latest version of Grafana, wherever that is, 8 something, I think. Cool. Okay, so there was some familiarity with what I was talking about, which probably helped.
Yeah, definitely. Cool. I mean, is there any questions before we wrap up? Nope. All good. Well, yeah. Again, thanks a lot, Rupert, and thanks a lot for to YellowDog as well. Thanks a lot for giving up your time. I think that was quite that was pretty cool, and it's a good welcome return to some sort of live demo, live coding to our meetups. So that's very much appreciated. We've got our meetup booked up, I think, for August already. I don't have the details, unfortunately, but they will be out later on this week. Yeah, we'll get the details out to you. Yeah, later on we'll find you somehow. Any face-to-face meets? At the moment, probably not, or certainly nothing in the offing. I think we're just sort of keen just to take stock, just to see what happens later on in the year. Certainly something that we're keen to get back doing, just in terms of having physical meetups. But not on the agenda, certainly not for the next few months, I'd say, because I know everyone is keen to have a slice of pizza and a beer while listening to people like Rupert talk. I certainly missed that, but yeah, certainly not at the moment. But you never know what what's to come in the next few months. But yeah, thanks a lot for. Well, yeah, thanks a lot for coming again, and Rupert, thanks a lot again for having us.
Thanks very much for your time. I really appreciate it. It's been a pleasure.
Cheers. Thanks a lot, everyone. Have a good evening.